Hi, in this video we'll be going over the continuation of the C# video tutorials, csharp.net. So we'll be going over class. So we'll be starting with classes, just talking about classes, a class's responsibilities. So basically a class's responsibilities are the things that the class is responsible for knowing and the actions that the class is responsible for doing. There's some more theory things. I'm probably just going to skip most of it. Just a bit about the problem domain, some method and class stuff. I think I've talked about this like here and there. So I'm just going to skip that part. So we're going to talk a little bit about it in the class itself. So first we're going to create a customer class. So I'm in Rider. You can do this in Visual Studio, whatever you want to use. So I'm just going to go to the Solutions Explorer. I'm going to find the class. Then I'm going to open. So I'm just going to go Add and then Class/Interface. Okay. Something's glitching out here. Let's just try that again. There we go. Okay, so let me choose something. So I'm just going to call this customer class. Hit enter. Something should be generated. We're going to have to, if you're in Rider, you're going to have to copy these using directives over to the other file like that. Or you can just write them out, whatever you want to do. I'm just going to copy it out just to save some time. Okay, so we have pretty much just a public class, like a customer class here. So the context of our problem domain. Okay, so what's a problem domain? So let's just go back here for 1 sec. You've seen this in any object-oriented textbook. It's the same every time. So basically, there's some steps here. So when developing an OOP or object-oriented programming or object-oriented program, one of your first tasks is to identify the classes that you will need to create. So let's say you're working at some place doing software development, so you need to know what class you need to create or what classes you need to create. So typically your goal is to create the different types. So basically you take the real world objects that are present in the problem and create classes for those types of objects within your application. So if you have like a database, you could say that, okay, well, we have a database class. The data is going to be going through here. You kind of just start setting it up. So maybe where the data is going, where the data is coming from, where is the data going? Or where is the data going and where is the data coming from? Something like that to start. So there's like a conventional way to start. Okay, so pretty much software professionals have developed like some techniques for finding the classes in a given problem in OOP. So one simple technique, basically, so this is just one common way. So remember, the goal is to identify the different types of real-world objects that are present in the problem and then create classes for those objects within your app or whatever. Pretty much it's going to be an app. Pretty much the first step is to get a written description of the problem domain. So if you're working with a client or a team or your boss or something, get a written description of the problem domain. So get everything in writing. Second part is identify all the nouns, including pronouns and noun phrases in the descriptions Excuse me. So these will be a potential class. So for example, you could have a class called database that we just said, well, that I just said a second ago. So you could refine the list to include only the classes that are relevant to the problem. So extra classes may be like extra things. For example, like internet service or something, you could maybe skip some of those. I don't know, I'm not really sure, just an example. If it's like a kind of like some kind of social app, then well, you'd need, for example, that's going to be a big project. Well, it's not going to be like super impossible, but you're going to have different, like you, for example, you'd have like, I don't know, like a user class. So the user class you may be using millions of times, right? To create user objects. You could have a loop to create them. You could store them in a list as we did. Just different things like that. So writing a description of the problem domain. So the problem domain is the set of real-world objects, parties, and major events related to the problem. So that's a test question as well. These are all test questions, like written multiple choice questions. So I'm just gonna, pretty much that's gonna be it. Let's go back to the code now. Sorry about that. Someone's just revving their rice box outside. Okay, so we have we basically have a customer class here to start. So in the context of our problem domain, what must the customer class know? So the description directly mentions, for example, the customer's name, the customer's address, and the customer's telephone number. These are all values that can be represented as strings and stored as properties in C#. The customer class can potentially know many other things. It's just an example. So you don't want to have too many things that an object is responsible for knowing. Like maybe you don't want like the customer's height or weight or something, or I don't know, like if the customer's male or female or whatever, neither of those, then maybe you'd have, I don't know, a customer's pet's name, like things you wouldn't want to include to save memory, to save app space, because remember, you're going to have to store this later on in like a database. For example, like, what's that one? There's that one, I think it's called Firebase, that a lot of people are using. You can get started for free. That's a common one. We'll be talking about that stuff later on. So pretty much, you don't want to be storing too much data in that space because it's going to cost money to store your app data, unless you create the whole thing yourself, which is possible. Like you create the whole database yourself, so you have to be really smart to do that. So we'll be talking about network stuff later on. Okay, so you basically just want to keep the objects, or you want to keep the instance data to a minimum. Okay, so for example, oops, sorry, just hit the mic, my headset by accident. Okay, so you don't want to include too much instance data for the object. So for example, in an app, a customer class might know the customer's email address, for example, the name, address, just things you need. You might not want like the color of the customer's car or something like that. Unless you're like a repo service or something. Okay, so let's identify the class's methods. In the context of our problem domain, what must the customer class do? The only obvious actions are going to be, so the customer class, what is it going to do? So we want to, so what are we going to do? So we're going to create and initialize an object of the customer class, get and set the customer name, get and set the customer address, and get and set the customer's telephone number. So you can, in C#, getting and setting is done. There's two ways to do it. You can do it the normal way, or you can do it with properties. So I think in this case, these docs are talking about doing it with properties. That's why it doesn't say create getters and setters, perhaps. But get and set work for C#. If you're gonna do a normal getter and setter, you can just create those yourself, or you can auto-generate them with a right click in most IDEs. I think even in Eclipse you can do that, which isn't very good. But at least you can do that. Okay, so we have a class here, so we'll just call that, so we have public class customer, so we can write this out again. We'll just comment this out. Okay, so we'll just go down here. Oh. Okay, so we'll just say this, whatever namespace this is, so it's, I just have them adding to each other. So namespace Windows Forms app 22, or sorry, 27. We'll just open a block here, we'll just say public class customer. Open another block. Okay, so we'll have our backing fields here. So we'll say we have a private string, we'll say that we'll just call it underscore name. Private string underscore address. And private string underscore phone, or just phone, whatever. Let's go with phone number. Okay, so here we'll have our constructor. So we're going to actually point the backing fields to parameters that are going to be inputted. Then we'll get and set the backing fields. So I'm not sure if we did this yet. So maybe it's just some advanced object stuff, class and object stuff. So here we'll just to create the constructor, we just reference the class name, so public customer, like that. So here we'll have some parameters, so we'll say that it takes a string name, string address, and a string phone number, like that. Okay, so here we're just going to point the backing fields to the parameters, so we'll just reference, for example, usually just go down in the order they are, like this. So they'll have like the first one here, underscore name with name, like that. Then we'll just continue address with address and phone number with phone number. We'll take the backing field underscore name, we'll point it to the name parameter like this. If you have the same, okay, so for example, for example in Java, you can just take, instead of the, because you can't, there's no backing fields in Java, I think, well, at least you don't use them normally, so you have just fields, there's no backing fields. I just say like basically just global variables and stuff. So you just take your underscore, or your instance data, so you just take your name here, it'll be like this. And instead, you can use the this keyword, so this is where you use the this. This is where you use the this keyword. So this actually works. The reason why is because, excuse me, so the reason why is because this accesses, so that this keyword accesses the object's instance data. Not, so when you go this, it points up to the fields. Look how we have two names here. That's why I usually call things the same thing. Excuse me. So if I take the this out, what happens? There could be confusion. So this might work as well. So in C# the this keyword might work. Okay, so this name is telling me that it's a field right here. It's telling me that it's a field, and this one is going to be different. Okay, I'm not sure how I got it to tell me it's a field. I don't think you can see these extra pop-ups, but I'm just going to, in writer, I'm just going to hit the dot operator. I'm going to hover over the IntelliSense. And it's just telling me that it's showing me that it's basically that it's a field. It's telling me that. So that's the correct one. Now if I go for here, name, it's just telling me that it's a string. It's not telling me that it's a field. It says parameter string name. So that should be correct because it's a parameter, but it's not the field. So this works. But if I just go like this instead, name, it's telling me it's a parameter field. Sorry, it's not a field. It's telling me it's a parameter string name. So not a field. Sorry for the confusion. It's saying that it's a parameter string name. And these two are just pointing to each other, so it's pointing to itself. Name points to itself. That's what's happening here. That's why it's gone gray, to show that it's just redundant. Basically, it's not doing anything yet. But if I go this dot name and hover over it, it's telling me that it's a field. So that's what you can do in Java. That it seems to be working in C# as well. In C++, I think you can do the same thing. You might be able to. The syntax for C++ might be a little different though, because you use the colon. But anyways, here we have, for example, underscore name, so we're just going to keep it with that. But you could do that. In this case, now it's telling me that, well, why using the this keyword? Because it's redundant. That's true because we don't need the this keyword now, because we're not pointing the same name to its parameter. So in this case, we'll just go with underscore name, points to name. Now we'll go with underscore as. We'll just set the rest of the backing fields. We'll go with underscore address points to address. So if you want, you can name your backing fields the same thing. The convention is to do it with an underscore. If you don't have backing fields and you just want to have a field and just point them like that, that works with the this keyword too. So it's up to you. So here we have underscore phone number points to phone number. Oops. Okay, so so the fields, the backing fields, and the constructor has been set up. So this will set up the object's instance data. So when you instantiate an object with a name, address, and phone number, the backing fields get set up. Well, not completely. Well, the backing fields are set up, yeah. Now we'll do the properties. Okay, so here we'll go with a name property. So we'll go with public. Whoops, sorry. So we'll go with public here. String. Remember to set up a field. There's no parameters. So we'll just make a note of that here. Sorry, not fields. Did I say fields? So remember, when you're setting up a property, there's no parameters. So we have, for example, properties have no parentheses. Hopefully I spelled it right. So there's no parameters and no parentheses. This isn't here. That thing's missing. Because that becomes a method. If we're not referencing the class name, if we're referencing the class name, it becomes a constructor. So properties have no parentheses. Excuse me, so here we'll say get. We'll open a block here. We'll say return underscore name. Then here we'll say set. Then we'll say underscore name points to value. That's it. So first property is set up, then we'll go to the next one. So what's the next property that we have? The next property is address. So remember, the type's going to be the same type that it is. So it's a string. So in this case, our properties type is just going to be the same. So public string, we want address like that. We'll open a block. We'll say get, open another block. We'll say return underscore address like that. We'll say set. Then we'll say underscore address points to value. Last one, so we'll go with, what's the last one? The last one is phone number. We'll say public string phone number like that. No parentheses, remember, for the properties have no parentheses. We'll say get, open a block, we'll say return address, sorry, not address, return phone number. Then here we'll say set, open a block, we'll say phone number, sorry, this should be have an underscore on it, my bad. Return underscore phone number, so return the backing field, and then here we'll say set, we'll say underscore phone number points to value. So let's just check all that here. So public string name, no parentheses for a property. Open a block, get, return underscore name, set underscore name points to value. Next one, public string address, no parentheses, get, return underscore address. Then set, open a block, underscore address, so the backing field points to value. Next one, public string phone number, no parentheses, get, return underscore phone number, and then set underscore phone number points to value. So that's the first class here. So there is 2 more to do. It's just practice, same thing. We're going to do the exact same thing with just a different one and different fields, backing fields. Okay, so this was the customer class. So the next one is going to be the, so the next one is going to be the cart class. So I'm just going to go to the top. I'm going to go, I'm going to go to the Solutions Explorer. I'm going to find the file Form1 under whatever this is. I'm just going to go back to the Form1 class. Then I'm going to find the file form1.cs. I don't think you really needed to do that, but that's okay. So we're going to go right click, add class/interface. I'm just going to go with this one, call it car, hit enter. I think those using directives are still saved in the stack. So I'll just Control V it to paste it. So we could just set up this again. Alright, so I'll just wait for the viewers to just set up their class if they're following along here. Okay, so we'll just move on to the next one now. So we're just going to do the same thing exactly with different backing fields. So we'll just go with namespace. I'm just going to call this whatever my namespace is. You can do the same for you. So I'm going to open a block after the namespace and then write the class inside. So public class car. Open a block. So this this class is going to have 3 backing fields. So I think we've done this before, but not with backing fields. So we'll say private string underscore make. And here we'll say private string underscore model. Then here we'll have a private int. We'll say that the int is an underscore year like that. Okay, so those are backing fields. So in the constructor, we're just going to reference a class name like that. Public car, we're going to open parentheses for some parameters. We'll say that it takes a string make. Oops. Something happened here. That's odd. Oh, sorry, I think I'm out of the class. Okay. So we'll just go under here, we'll say public, we'll just say car, and we'll say, for example, that we want our parameter to be string make. We'll say string model, and then we'll say int year, like that. Okay, so now we're just going to go underscore make points to make, underscore model points to model, and then underscore sorry, backing field underscore year points to year like that. Okay, so that should be fine here. So now we'll just set up the properties. So we'll go with public make, no parentheses because it's a property. Okay, whoops. I think that was a different. It auto-generated it. I think you can use this symbol, which we haven't talked about yet. I think that might be in a newer .NET framework. I'm just gonna go with this way. So I'm just gonna. Why is it doing that? Oh, sorry, I forgot the type. Okay, so we'll go public string here, make here, and then we're gonna open a block. Then here we'll just go with get. We'll say that we're going to return the backing field underscore make, and then set. We'll just say underscore make points to value. So for the next property, it is the model, so we'll go with the type as well. So the types, so it's just going to be public string, so the type is string. Because the property, the backing field is also a string, then we'll just call it model. No parentheses. We'll say get. We'll open a block here. We'll say that we want to return the underscore model. And then set, we want to open a block. And then we want to say underscore model points to value. That one's done. Then here we'll go with public int year, open a block. We'll say that we want to get, open a block. And we'll say that we want to return underscore year. Then we want to set underscore year points to value. Okay, so that one should be done. So we'll just double check it here. Okay, so we have public string make get, then return underscore make, set, then underscore make points of value. Okay, so public string model, get, open a block, return underscore model, set, open a block, underscore model points of value. Then we have year, so public int year, bearer property, open a block, get, return underscore year. Next one, set underscore, sorry, just set, open a block, then underscore year points of value. So that should be everything. Okay, so the next one is called service quote. So it's going to be our last practice. So I'm just going to go to the top. I'm going to I'm going to do the same thing. Sorry, no. I'm going to go to the Solutions Explorer. What's that thing? Okay, so we'll go with Form1.cs. I'm going to go add class / interface. I'm just going to call this service quote. Okay, so it's going to generate. We'll just have here the using directives. I'm just going to paste them in. Comment this out again. Just write that out. Oh, I think I named it wrong. Okay. Okay, I'm going to right click this, refactor, if I can. Can I? Refactor this. Rename. Okay, I'm just going to change the name here. I don't think it actually refactored anything. So I'm just gonna do a new one here. So I'm just gonna go right click, same thing. Okay, so I'm just gonna paste in the using directives at the top. Comment this out. Okay, so we'll just go with the namespace here. Namespace WindowsFormsApp27. Open a block. We'll say public class. Service quote. Open a block. We'll have. Okay, so in the context of our problem domain, what must an object of the service class know? The problem domain mentions the following items: estimated parts charges, or the estimated part charges, the estimated labor charges, the sales tax, the total estimated charges. So we have different things here. So careful thought and some brainstorming, some other, basically just going through everything that you need, reveals that these items are a result of the calculations. So sales tax and total estimated charges, instead of having, for example, the different charges as fields, we're going to just group them together as one. Okay, so now let's identify the class's methods in the context of our problem domain. So what must the service quote class do? We must create and initialize an object of the service quote class, which we probably won't do at this point. We're just going to set up the class. Get and set the estimated part charges, get and set the estimated labor charges, get and set the sales tax quote. Get and set the sales tax and get the total estimated charges. Okay, so actually there is two fields. So this one's going to be a bit of a longer one, so I think we'll actually do that in the next video. So there's some extra stuff to do. So if you're interested in seeing the rest of the tutorial or the series, it's on my channel in the csharp.net channel. In the csharp.net playlist on my channel. So thanks for watching, guys. If you guys like the video, you can like and subscribe to support the channel for more programming and investing tutorials. And the next video will be continuing with the next class, which is actually a longer one. I thought it was just going to be the same thing, but it's there's a bunch of stuff here to do. So thanks for watching, guys. I'll see you guys in the next one. Thanks. Take care.